Alright, so in this video, let us continue with more problems based on surface areas and volumes. And we've got a question here, which kind of looks lengthy, but don't worry about it. It's a very simple problem. It reads like this. Selvi's house has an overhead tank in the shape of a cylinder. Okay, now this is filled by pumping water from a sump, which is nothing but an underground tank, which is in the shape of a cuboid. Alright, so the things that I want you to notice now is the shapes. One is a cylinder, and then we've come across a cuboid. Let's see what's next. The sump has dimensions 1.57 meter into 1.44 meter into 0.95 meter. So the volume of the cuboid is done here. Length into breadth into height. Now, what's the question? The overhead tank has its radius of 60 centimeters and its height is 95 centimeters. Alright, we've got sufficient data here. So we've got the volume of the tank also almost. So now, find the height of the water left in the sump after the overhead tank has been completely filled with water from a sump which had been full. Compare the capacity of the tank with that of the sump. Pretty simple, I'll tell you what. Now, definitely the sump is going to be bigger than the overhead tank, okay? Simple logic. So let us first find the volumes of both, okay? Then definitely, whatever is the volume of the overhead tank, that's the same amount of water which would have got filled in the tank. So whatever is left, we just have to find the height of the water left, all right? So we will get that volume of the water, how much ever height, or just in the matter of subtraction, we'll get the volume of the water left. So using that volume, we can find the height, okay, because it is in the form of a cuboid, right? So that's all that there is to do. It is not at all complicated. Very simple sum. But if you haven't understood, don't worry, you'll understand as I solve the problem. So the first step is to find the volume of water in the overhead tank, or it's nothing but find the volume of the overhead tank. Which is in the shape of a cylinder, so therefore it's going to be pi r square h, which is 3.14 times the radius is 60 centimeters. So let's convert to meters since this is in meters. So it's going to be 0.6 times 0.6 times the height is 95 centimeters, that is 0.95 meters, right? So this is the volume of the overhead tank, or the volume of the water in the overhead tank, right? In meter cube it's given. So the next one is the volume of the water in the sump when it is full of water, or rather the volume of the sump. Volume of sump, or the volume of the underground tank, or whatever that is. You just have to multiply this, or you just have to write this 1.57 meters times 1.44 meters times 0.95 meter. You can either write meter into meter into meter, or write all the numbers and then write meter cube in the end. This is going to be the volume of the sump. So now what let's do is to make it more simpler, what I'm going to do is I'm going to write 1.57 meter as it is. Now I'm going to write 1.44 meters as 4 times 0.36 meters. Then I'm going to keep 0.95 meters the same, because just to make the calculations a little easier, a little later. So that's why. So now what we'll do is we'll just split 4 into 2, and 2 times 1.57 gives you 3.14, and then write times 2, right? What I'm doing here is, please notice carefully, I'm splitting 4 into 2 into 2, and I'm multiplying 2 with 1.57, which gives us 3.14, and then one more 2 is just taken down like this, and then I rewrite all these 0.36, 0.95 meters, right? Well, before that, let me also, simplify this and write it as 3.14 times 0.36 times 0.95. I think now you'll understand why I kind of changed this. You can see 3 terms are constant same here. So that's why. So you can clearly see that already the sump is 2 times the volume of the tank. You can clearly see that everything is same, but it is multiplied with a 2. Or let me rewrite it like this. So 2 times 3.14 times 0.36 times 0.95 meter cube. Alright, so yeah, this is also meter cube. So if you notice carefully, this is 2 times this. So the volume of the sump is 2 times the volume of the overhead tank. So that question is almost done. They're saying compare the capacity of the tank with that of the sump. When we compare, we can see that the sump is 2 times the size of the tank, or the 2 times the volume of the tank. So that's done. So now we just have to find the height of the water that is left in the overhead tank after it is being filled from the sump. So let's go to that. Now, just to avoid all the multiplication and all those things, because at the start of the problem, I told, we just have to find the volume of the overhead tank and volume of the sump, and you subtract both the volumes and you'll know what is the water left in the sump. But to avoid all these calculations, especially that you're not allowed to use the calculator, here is a nice way to do it to avoid all the calculations. So now, no doubt we are subtracting it, but then, we are not multiplying all these things. So now, the volume of water left in the sump after filling the overhead tank, it's going to be this minus this, right? Because so much volume is going to be taken away from here. So 2 times 3.14 multiplied by 0.36 into 0.95 meter cube minus 1 times 3.14 into 0.36.95 meter cube. We definitely are going to get just 3.14 times 0.36 times 0.95. It's like consider the whole, this factor 3.14, 0.36, 0.95 as x. So it's going to be 2x minus x, which is 1x. All right. So this is the volume of water left in the sump. Now, since that sump is of the shape of the cuboid, which is length into breadth into height, we can equate this to the volume. We already know the length into breadth. The length into breadth is 1.57 times 1.44. So that is one way of doing. Or another way of doing is, the volume of the cuboid is also equal to length into breadth into height. So the length into breadth is nothing but area. Area into height also gives the volume of the cuboidal tank, right? So let us only find the area. The area of the base of the sump is going to be 1.57 times 1.44, right? Which is nothing but, again, what I'm going to do is, to avoid the calculations, I'm going to write 1.57 into 1.44 as, alright, let me show it to you. 1.57 times 1.44 can be written as 1.57 multiplied by 1.44 can be written as 0.36 times 4. And when you split 4, just like this, 1.57 into 0.36 to 4 can be split as 2 into 2. And again, you just take 1, 2 and multiply it with 1.57 to get 3.14. And then you get 0.36 times 2. So this is the area, meters squared. This is the area of the base of the tank, right? So you multiply h to this, you get volume. So that becomes meter cube, right? If you multiply h to this, it becomes meter cube. So that's when you get the volume of the cuboidal tank. So now you can clearly see that h is the unknown here because we don't know what is the new height. The new height of the water after the overhead tank is filled, the water is not going to be the same as how it was. So this is the unknown now. Now this should be equated to, now this volume should be equated to the volume of the overhead tank, right? Which is nothing but 3.14 into 0.36 into 0.95, because we know that the capacity of the sump is 2 times that of the overhead tank. So that means the overhead tank is half of the sump. So once you fill water from the sump to the tank, half of your water is gone, right? So we can even avoid these calculations and we can straight away do 0.95 divided by 2. That is one option. But well, if it is not exactly half, you can come back to this. So you're going to get h equals this 3.14 times 0.36 times 0.95 divided by 3.14 times 0.336 times 2. So you have 3.14 and 0.36 getting cancelled, and eventually you have 0.95 by 2, which is equal to, this is 0.95 meters, right? So you'll get 0.475 meters or 47.5 centimeters. So this is the height of water that will be left. So now that the problem is over, let me, briefly give you a revisit to the whole problem. Now see, Selvi's house has got an overhead tank in the shape of a cylinder. important point here, cylinder, because the volume of a cylinder is pi r square h, and this is filled by pumping water from a sump which is underground, and that is in the shape of a cuboid whose volume is length and breadth and height. Given here clearly the dimensions, which is length, breadth, and height. So the height is here. So one of the easiest way to solve this problem is, once you figure out that the volume of the sump is 2 times the volume of the overhead tank, then you know that this overhead tank takes away half the water from here. So if half the water is gone, what's going to change is only the height. The length and the breadth are going to remain the same, right? I'll just show that to you. Say for example, you've got a tank like this and it is, say, filled full of water. When you take away some water, again in the same container, the water level is going to come down. The length and the breadth is going to be the same, right? Obviously, because water can't be, only one side partially. So it has to spread out. So the height is going to come down. So definitely this height also would have been halved. If half the water goes, the height also comes down by half. That's your answer ends here itself. You get 47.5 right here. But what if it is not half? Then you'll have to do all these steps. You'll have to, subtract the volume of water that left the sump and then the volume of the water that is already in the sump, and you'll have to use all these formulae. So that's all. So this ends this problem. I'll see you in the forthcoming videos with more problems based on surface areas and volumes.